So now we'll touch upon a little bit about solubility. So continuing from 5.2, 5.3 is molarity and solubility. So with an ionic compound, if you remember, it is composed of a metal and a non-metal. A nice example is sodium chloride, NaCl. And we know that when we put water or salt in a cup of water, it will dissolve. And why is that? It will dissociate. And why is that? It's because we know water now is a polar molecule. It has the oxygen, which is partially negative, and the hydrogen, which is partially positive. The partially negative will go towards the Na, and the partially negative will go towards the Na, and the partially positive part, which is the hydrogen, will go towards the chloride. So if you look here, it dissociates and we have the Cl minus, which is surrounded by water molecules, the hydrogen end, and we have the sodium, which is surrounded by water molecules, particularly the oxygen end, the negative. And this happens over and over again, and eventually all of the salt will dissolve. So ionic compounds also do this with polyatomic ions, which dissociate. Remember, the polyatomic ion will stay together. So in this case, SO4, sulfate, will stay together. The S and the O do not break up. It's covalently bound. And when you do the balanced chemical equations, you see there's 2 sodiums on the left, 2 on the right, and 1 sulfate on the left and 1 on the right. Now, this is a water solubility table, ionic compounds. You don't have to memorize, but what this table is telling you is if on the left here we have the ions, nitrates, chlorides, sulfates, carbonates, hydroxides, and sulfides, it's telling you that it will dissolve, it will be aqueous in all, for instance, this first one, group 1 metals, it will be soluble in everything, no exceptions. If we look at chlorides, a little bit more detail, it's soluble in almost everything except with silver, Ag, mercury, Hg, or lead, Pb. Again, you don't have to memorize the exceptions, but you have to understand how to use the table. And for instance, for carbonates, it's mostly insoluble, so it'll form a precipitate, it'll form a solid, but the exceptions are group 1 metals, which is on the left side of the periodic table, and ammonium. So these ones will be soluble, but most will be insoluble when working with carbonates. So let's try this using the table. The name here, I'll let you know, it's lead 2 nitrate. Is this soluble in water? Well, if we look at the nitrates here, it's soluble in everything, no exceptions. So yes, lead 2 nitrate is soluble. How about calcium sulfate? Again, with the sulfates, they're mostly soluble. The exceptions are strontium, barium, lead, and silver. This is not any of those, so yes to soluble. And for aluminum hydroxide, the hydroxides, almost everything is insoluble, with the exception of group 1 metals, the alkali metals, and ammonium. So this one will be insoluble. It will form a precipitate. It will not be soluble in water. Ionic compounds and electrolytes. Well, when ions dissociate, for instance, NaCl, it will conduct electricity. It will form electrolytes. Those electrolytes would be sodium and chloride, meaning that if I had sodium chloride in this beaker and I connected it to a circuit, the light would turn on because of the current that flows through this system, because the ions as well helps the current flow in making a light. However, sugar, which is a non-covalent compound, it's made up of carbon, oxygen, and hydrogens. This is a non-electrolyte. I mean, when you put this in water, the carbon and oxygen and hydrogen, they'll stay together. You will not make ions. Hence, you will not get the light shining here. This is for A. And what we wanted to say is the dissociation of ions close the gap and make a circuit. So again, the sugar does not, because it is non-electrolyte, and the sodium does, because as we said earlier, when you put sodium chloride in water, it breaks up into ions. So we have strong electrolytes, things that break up into ions 100%. We have also weak electrolytes, something such as acetic acid, which only partially dissociates. And we talked about earlier non-electrolytes. When you put them in water, they don't break up into ions. Examples include sugar. It will not break up, and you will not get a positive light test. We have this saying like dissolves like, and you can probably see this experimentally. When you put ethanol, which is a big component of alcohol that we drink, we put it in water. Water is polar, so I'll just write here H2O is polar. So if you put ethanol in water, it will dissolve. You will only see one thing, so it's a polar compound. If, for instance, we had oil, which is a non-polar compound, when you put oil in water, you will see two layers, meaning that it does not dissolve. So those are not like and like. So again, you do the experiment with oil and water, they don't mix, you'll see a layer of oil and water. However, if you mix a non-polar, for instance, oil, with another non-polar solvent such as gasoline, they will mix and you will only see one thing. So the key concept here is like dissolves like, polar likes polar, and non-polar likes non-polar. You'll see one thing. However, if you have a non-polar with a polar, you'll actually see two layers. That's what I wanted to conclude for solubility.